Okay, so some of the rules we have seen, we will just revise those rules. So how do we find this? We have the linear differential equation phi of d acting on y is equal to f of x. Then in shortcut method, yp will be given by 1 upon phi of d acting on the function f of x. So this is the overall idea in general method as well as the shortcut method. So we study how this function 1 upon phi of d operates on the function f of x. Okay, so the first rule that we saw was 1 upon phi of d e to the power ax. So if your function is specifically of the type e to the power ax, then we replace d by a, and what we get is 1 upon phi of a e to the power ax. Then there is the case of failure. The case of failure says that if phi of a is equal to 0. If phi of a turns out to be 0, then what we do is we multiply the numerator by x. We take phi dash of a e to the power x. Then again phi dash of a also can be 0. Then what we do is we once again take the derivative, multiply the numerator by x, so that will become x square upon phi double dash of a e to the power x, and so on. This was the first case. The second case what we saw was 1 upon phi of d square sine of ax. In this case, we replace d square, so that will become 1 upon phi of minus a square sine of ax. The same thing for cos, 1 upon phi of d square cos of ax. That will turn out to be 1 upon phi of minus a square cos of ax. We have seen that how we convert each and every term in a polynomial in terms of d square, and at the end whatever d is surviving we rationalize it. Okay, in this case too there is a case of failure. If phi of minus a square turns out to be 0, then once again the same thing, multiply the numerator by x, take the derivative of denominator sine of x, or x upon phi dash of minus a square cos of ax, whichever is your function. Okay, and so on. The third one that we have seen is 1 upon phi of d square sine h, which is called sine hyperbolic. For sine hyperbolic, we don't replace by minus a square, we replace it by phi of a square sine h of ax. The same thing for cos, 1 upon phi of d square cos h of ax is equal to 1 upon phi of a square cos h of x. So for a hyperbolic function, you replace d square by a square, and for our regular trigonometric functions, we replace d square by minus of a square. How to use this rules? We have solved some examples on this. Then after this, what we saw was 1 upon phi of d x raised to m type of functions. So we know one thing about x raised to m, that mth derivative of m plus 1th, I should say, m plus 1th derivative of x raised to m is 0. So this is the small logic that we use here. What we do is we convert this phi of d in the form 1 plus psi of d, or 1 upon 1 minus psi of d. Okay, you have to convert it in one of these form and use the series 1 upon 1 minus x, 1 upon 1 plus x. 1 upon 1 minus x is 1 plus x square plus x cube plus so on. And 1 upon 1 plus x is 1 minus x plus x square minus x cube and so on. So this type of series we have to use in this. And then how many terms I should take? Always whatever is the power of x. So x raised to m is there, then what I will go is I will go up to x raised to m, because the next term will be 0. Again, an example on this we have solved. If not, please let me know. Maybe I'm wrong. We have solved an example on that. So I'll go to
Yes,
the
sir.
next rule, case number 5. So case number 5 says that if f of x is equal to e to the power ax into a function v, where v is any function of x. This is a very important rule, which is also called as exponential shift. Exponential shift. Till now, whatever rules we have seen, there was e to the power ax, sine ax, then x raised to m. There was just one function there, I mean, at the place of f of x. But now there is a difference. Now there is a product of two functions, e to the power ax into v. So you should be, I mean, very clear which rule is to be used. That is the only idea here. You are not doing integration, you are not doing anything else. What you will be doing is you are just identifying the function f of x, and accordingly you are using the rule. So now, what is the rule? The rule says that 1 upon phi of d e to the power ax into v is equal to e to the power ax 1 upon phi of d plus a acting on v. Anyone would like to elaborate what this rule says? Anyone would like to elaborate? What is the rule?
We will add plus a, then we will use the case 1 e to the power ax.
Whichever v is. V is not defined. So which case is to be used later? That
Yes.
is, I mean, that will depend on v. What is v? Accordingly, we'll use the other case. But what we are doing in this rule? What is special? What is the
Adding
difference?
adding a to the derivative. D.
Adding a to the derivative d plus a. Okay. And what it is doing after making replacing d by d plus a? What you are doing? What you are doing? What is happening in this rule? What is happening to e to the power ax? Shaunak? Okay,
How?
Yash. Okay, Yash, you can speak. What you are doing here?
Uh,
We are
we
separating e raised to ax from v.
make the we
Huh, you are separating, but it is coming out of the operator. If you look at the rule, what is our operator? 1 upon 5 of d. And replacing d by d plus a in the polynomial, what will happen is e to the power ax will come outside. It means that this e to the power ax is shifted. I mean, it is outside the operator. Now we are not anymore concerned about e to the power ax. What we have to think is how will 1 upon 5 of d plus a operate on v. That is the rule case number 5. And it is very important because product is there, and whatever rules we had till now are simply one function. There is no product anywhere in the previous rules. So what we have to do is we have to remove this e to the power ax. And how do you remove it outside? I mean, outside this phi of d is by replacing d by d plus a. Okay. A small example on this. Example. Example. Find the particular solution for d square minus 4d plus 3 acting on y is equal to x cube e to the power 2x. So finding out the particular solution, you can see the right hand side. There is e to the power 2x into some function. There is a product. Okay. So we have the rule for x cube. We have the rule for e to the power 2x, but you didn't had the rule for product. So what we'll do is we will remove e to the power 2x outside. So yp will be given by 1 upon d square minus 4d plus 3 x cube e to the power 2x. Okay. Now I have e to the power x inside. By case number 5, I can bring it outside. But what I will have to do, what will
Add
I have
two
add to where?
with d.
So what will be the expression?
D square minus 4d plus 2.
Uh,
Sorry, 4, then bracket d plus.
okay. Anything else? Anyone want to say anything else?
So d square minus 4d plus 5.
Anyone else? Rohit Sharma, what do you want to say? Rohit Sharma is absent. Okay. Janvi Mohite. Janvi Mohite, you want to say something?
No, sir.
No. Uh, Tanishq Kulkarni.
Yes, sir.
Uh, what we will have to replace to take e to the power 2x outside?
Mm,
Don't know.
Sir, d square minus ud plus ud.
Plus
What is 4d है क्या वो?
let me check. Yes, it is 4D.
Then we should add 4d.
Why? To make it complete square. What will happen then? Okay, Taha Sheikh. Taha Sheikh, you want to say something?
no, sir.
No. Shrutika Shinde.
D square minus 4D plus 5.
Okay. Raj.
Yes, sir.
You want to say something? What will be the right hand
Actually,
side? Huh?
I think that d square minus 5d plus 4 it will be.
Okay. Okay. So I'll come back to Yash, Dhruv, Raunak, and I will write down here phi of d as d square minus 4d plus 3, and I will write down phi of d plus 1, and okay, let's not go to d plus 1. Phi of 3, what it will be? Yash,
3
Yash, what this will be?
Yes, sir.
Phi of 3 क्या होगा? Dhruv, what will be phi of 3?
3 square minus 4 into 3 plus 3.
Okay, 3 square minus 4 into 3 plus 3. Then when I say, okay, now phi of say d plus 3. So what you have done for 3? What you have done on the right hand side, you have replaced d by
Substituted.
3. जहाँ जहाँ d है वहाँ पे 3 रखा है. तो
सर
phi of d plus 3 क्या होगा? Tell me.
सर रूट्स निकाल सकते हैं d स्क्वायर माइनस 4d प्लस 3 के.
Who is it? Shaunak, no. Dhruv, tell me.
Um,
What will be 5d plus 3 now? ये इसने क्या किया है यश ने यहाँ पे 5 of 3 is equal to 3 square minus 4 into 3 plus 3. What he has done?
replace d by 3.
Okay. So जहाँ जहाँ d था वहाँ पे 3 रख दिया है. तो 5 of d plus 3 में क्या होगा?
Same.
Same. तो बोलो
d
ना क्या
plus
होगा?
3 the whole square
d plus 3 the whole square
minus 4 into bracket में d plus 3 then plus
plus.
3.
So this is the meaning of that rule. You are replacing d by d plus 3. Okay, it is not plus 3 to whole equation. So what you were doing was you were simply adding 2 here at the end. है ना? This was what you were doing. But this is not the meaning of that rule. That rule says that d जहाँ जहाँ है वहाँ पे तुम्हें क्या रखना है? d plus 2. So in this case, you have took e to the power 2x outside. So first term will be d plus 2 square minus 4 d plus 2 plus 3. I hope I have made myself very clear about this.
Yes, sir.
So now you can simply simplify this expression d square plus 4d plus 4 minus 4d minus 8 plus 3 x cube. So this will be equal to e to the power 2x 1 upon
D square minus 1.
4d square minus 1 x cube. Okay.
सर एक क्वेश्चन था,
हाँ
मतलब
this
हर जगह जो ई का पावर है वो सब्स्टिट्यूट करना है ना, d+2 ऐसे।
किसका पावर?
अभी अपन ने d+2 सब्स्टिट्यूट किया ना, तो वो
हाँ
+2 ही करना है क्या? ई का पावर जो रहेगा वो
हाँ,
सब्स्टिट्यूट
ई
करना
का
है?
पावर जो रहेगा वो सब्स्टिट्यूट करना है। यहाँ पे e टू द पावर 2x है, तो ये जो 2 है वो ऐड करते हो तुम वहाँ पे। अब अगर सपोज यहाँ पे e टू द पावर 3x होता तो मैं यहाँ पे d प्लस 3 स्क्वायर कर देता। ओके,
ओके सर।
हाँ। नाउ व्हाट यू हैव टू डू, इसके आगे का तुम्हें पता है ना। सो दिस विल बी इक्वल टू e to the power 2x. I'll take minus sign common, 1 upon 1 minus d square x cube. अब तुम्हारा क्या है यहाँ पे, 1 upon 5d के आगे क्या है? x क्यूब है। x क्यूब का कौन सा रूल है तुम्हारे पास?
1 up.
रूल नंबर, हाँ, 1 upon
Rule number 4.
rule number 4. So what we will have to do here, we will have to use rule number 4 and it says that 1 upon 1 minus x कैसा दिखता है? 1 plus x plus x स्क्वायर। कहाँ तक जाना पड़ेगा मुझे? x क्यूब
Cube.
है तो
हम्म।
ओनली पावर 3 तक जाना है, आगे का सब छोड़ देना है, तो x क्यूब। So if you simplify this, what I am going to get? d raised to 4. So fourth derivative of x cube is 0. So we'll remove this term. 1 plus d square x cube. Now open the bracket, minus e to the power 2x x cube plus d square x cube. Now Janvi Mohite, what is d square x cube? Tanishq, what is d square x cube? Tanish Desai, what is d square x cube? Look, this is not, I'm not asking for, I mean, casually. I'm getting an idea of each and every person from this. So please pay attention and answer when I'm asking, because I have to give you marks out of 50 in tutorials as well as 50 other.
So 6x.
सर x³ अपॉन x³ माइनस ई स्क्वायर एक्स, सॉरी डिनोमिनेटर में जाए x³ माइनस 1/e²x।
No,
So
d
6x.
square x, d
6x.
square x cube is, yes, it is 6x. Wait, so d square is nothing, d is nothing but derivative. So d square मतलब 2 बार डेरिवेटिव। x क्यूब का फर्स्ट डेरिवेटिव आ जाएगा 3x स्क्वायर एंड सेकेंड डेरिवेटिव विल बी 6x। So this will be minus e to the power 2x x cube plus 6x. This is your yp and the particular integral. Fine. Now just let me make this clear. If I change the question, I've cut the part and now I'm saying solve. What will be the change in solution?
YC भी ऐड करना होगा.
yc भी add करना होगा. So you will have to find yc. मतलब that will be the, you will find out the roots of this auxiliary equation d square minus 4d plus 3 equal to 0. Depending on that you will write yc and final solution will be y is equal to yc plus yp. Fine. The next rule, and this will be the last one, case number 6. The case number 6 is that if f of x is equal to x into v, where v is a function of x. Then 1 upon phi of d x into v. What is the difference between the fifth and the sixth rule? Ganesh Desai, what is the difference between fifth and sixth rule?
Sir, it is a function of v. मतलब d ने replace केले.
Okay. Ganesh Desai.
Yes, sir.
So please tell me what is the difference between fifth and sixth rule?
Don't.
F of x मध्ये काय? What is the difference in f of x of fifth rule and sixth rule?
Sir, don't know.
Don't know. Ganesh Nagre. Anish Kulkarni left. Okay, fine. Can you tell me, Dhruv? Dhruv, what is the difference in f of x for fifth and sixth rule?
I think that x and v will multiply. I mean, the powers will add up.
X and v are in multiplication. Okay. Major difference क्या है in f of x for the
Both
rule
are
number 5?
x.
Both are for product. And if you see here, in the previous rule, f of x was e to the power ax into some function v. Okay, this was the rule number 5 was for this. There was e to the power ax into some function, whereas now f of x is again the product of two functions, but now it is of x into some v. Okay, this is the major difference in two rules. X is multiplied here, whereas in the previous one e to the power ax was multiplied to some function. Okay, so agar x into v hai, then you go for rule number 6. If it is e to the power ax into v, then you have to go for rule number 5. And what does rule number 6 says? Rule number 6 says that if f of x is equal to x into v, then 1 upon phi of dx into v is equal to x minus phi dash of d upon phi of d, bracket complete, 1 upon phi of d acting on v. So as you can see here, to x is removed from the calculation. I mean to say that you are not applying phi of d on x. X is here. 1 upon phi of d you have to separately apply just on v. Then we will open the bracket and the rule will be applied to complete this. Okay, it looks complicated, but once you memorize it and when you will be solving examples, it will be very easy. So example on this, remember this: x minus derivative upon phi of d, bracket complete, 1 upon phi of d acting on v. Okay, so example, find the particular solution, a particular integral for d2y by dx square plus 4y is equal to x sin x. So I can write this differential equation as there are two derivatives. So d square plus 4 bracket complete y is equal to x sin x. I can see the right hand side. Right hand side is x into v, where v is sin x in this case. So this is the way you have to identify which rule is to be used. So yp will be equal to 1 upon d square plus 4 x into sin x. So by rule number 6, what will happen? X minus, what is derivative of d square plus 4? It is simply 2d upon d square plus 4 as it is, bracket complete, 1 upon d square plus 4 sin x. I will write the rule over here just because I want you to understand. 1 upon phi of d x into v is equal to x minus phi dash of d upon phi of d, bracket complete, 1 upon phi of d acting on v. Please check it, compare both of them so that you will understand what I am doing over here. Okay, now x minus 2d upon d square plus 4. I just want to ask you now, what is the rule for sin x, sin ax?
Replace d
Go
by
to replace d by,
1.
are you sure? Is it
Sir,
replace d by?
sir, d square by minus a square.
So what is your a in this case? A is 1. Okay, so minus of a square will be minus 1. right? And 1 upon pi of d square. The rule is d square. Yes. So in this case, d square will be replaced by minus 1 sine of ax. And in this case, it is a is equal to 1, so simply sine x. Okay. So we'll replace d square. D square is here. So 1 upon minus 1 plus 4 sine x. If you have any problem up to this, please ask. So I think it is clear now. So I'll go ahead. So this will be x minus 2d upon d square plus 4. Am I audible?
Yes, sir.
Yeah. So minus 1 plus 4 will be 1 by 3 sine x. So this will be 1 by 3 being constant. I can bring it outside. I can open the bracket and I will have x sine x minus 2d upon d square plus 4 sine x. Look, when I'm writing this kind of expression 2d upon d square plus 4, I can operate numerator first or I can operate denominator first, whichever I like. Okay, so I would like to do it in this pattern. 2d 1 upon d square plus 4 sine x. Okay, so 1 upon d square plus 4 sine x, by the rule for 1 upon phi of d square sine x, this d square will be replaced by minus 1 and minus 1 plus 4 will become 3. So 2 by 3 d sine x. So now d sine x is equal to Atharva. Okay, someone else is Rutul. Rutul?
Yes, sir.
What is d sine x? No, I'm making this clear. I will have to lock the meeting if this is the case. Our lecture is till 10:30 and many of them I'm observing that they are coming at 10 o'clock, 10:15 and or else what I will do is after 5 minutes I'll take the attendance. I'm being good, it doesn't mean that I can't uh, take any kind of actions. So please
Sir, no,
be,
I was trying to join, but first at 9:50, but you were not adding, so I thought I was not in the group. That's why I told others to, but
you're not
afterwards
in
I
the class group.
disconnected. Sir, I am, but I told others to tell you that please tell sir to let me in, but I
But
disconnected
still,
afterwards.
Rutul, but still 9:50 is late, right? It is
Yes,
almost
sir.
20 minutes late.
Yes, sir.
It is,
Sir,
and it is
some
not.
people get locked out due to network issues.
Yes, sir. That's all.
A
Sorry, sir. It
network.
will not happen again, sir.
Okay, fine. So d of
Cos x.
the derivative of sine x,
Cos x.
1 by 3 x sine x minus 2 by 3 cos x. So this is our yp. So the rule is clear now. We'll solve one more example on the same rule, and the question is solve d square minus 2d plus 1 y is equal to x e to the power x sin x. So since the question is solved, I should find out yc as well as yp. So first of all, the auxiliary equation d square minus 2d plus 1 is equal to 0. So this is simply d minus 1 square is equal to 0, which means that d is equal to 1 comma 1. So yc is equal to c1 plus c2 x e to the power x, since 1 is real and it is repeated. Now yp will be given by 1 upon d square minus 2d plus 1 x e to the power x sin x. Which rule?
So last fifth,
Fifth.
sixth.
What's the problem with fifth? Why can't I use the fifth one?
Sir, because x is also there in this.
हाँ, e to the power
Fifth.
x is also there.
सर अगर सिर्फ e रेस्ट टू एक्स साइन एक्स होता तो हम फिफ्थ रूल यूज कर सकते थे.
Okay. In this question, I can write this in both the forms. Like, we don't have any condition on v कि v कैसा होना चाहिए. Okay, there is no condition on it. I can consider this as e to the power x in bracket x sin x. So this will be your v and e to the power x into v. Rule number 5. Okay, this is the fifth rule. And I can also write this down as x in bracket e to the power x sin x. So this will become rule number 6. Okay. So the problem is here, I can use both of them. So I will have to think which is convenient for me. Okay. As you can see to the rule number 6, it is difficult to use. I mean, there is the derivative of phi of d upon phi of d bracket complete, and again you are taking this 1 upon phi of d. Okay, so what we will do is we will use the rule number 5 first. So you to remember this, whenever both the rules are applicable like this, as I have written on the right hand side, what we will do is we will use the rule number 5 and remove e to the power x from the calculations, because rule number 5 is easy and it directly removes e to the power x. So always give first priority to rule number 5 and then rule number 6. Okay, because rule number 6 is quite difficult than rule number 5. So what I will do here, I'll write down d square minus 2d plus 1 e to the power x in bracket x sin x. So I'll take e to the power x outside this, and I will replace d by
D plus 1.
d plus 1 minus 2 times d plus 1 plus 1, and you will have x sin x. So this is e to the power x upon, so d square, I'll simplify it at the bottom, d square plus 2d plus 1, the first term, minus 2d minus 2, the last one is plus 1. So minus 2d plus 2d gets cancelled out, plus 2 minus 2 will get cancelled out. We have 1 upon d square x sin x. Now what I can do is 1 upon d square is nothing but
Minus A square.
minus a square. No. Minus a square is when there is just sin x. But here what you have is x into sin x. So you cannot replace d square directly.
We have to apply rule 6.
Now we will have to apply rule 6. Or what is 1 upon d square? My question is this. Of course you will apply rule 6 here. But what is 1 upon d square? I am telling you the alternative for the rule number 6 here. What will you do if it is 1 upon d sin x, x sin x? What is d? D is derivative. So 1 upon d logically has to be
Derivative.
d is derivative. 1 upon d has to be inverse of derivative. What is inverse of derivative? It is integration. So when we say 1 upon d square, I will have to take 2 times the integration of this. That is one way. And it is a difficult one. So we'll use rule number 6. Rule number 6 says that in bracket x minus, what is your phi of d? Phi of d is d square. Take the derivative of phi of d, this 2d upon d square, bracket complete, 1 upon d square sin x. This is rule number 6. 1 d will get cancelled out here. So what we have is e to the power x minus 2 by d square here will be replaced by minus of a square, and it is 1. So minus 1 sin x. So minus will come outside, minus e to the power x, open the bracket, x sin x minus 2 by d sin x. Now 1 upon d is integration. Take the integration of sin x sin x. Integration of sin x is Kanishk Kulkarni. What is derivative of sin, integration of sin x?
Minus cos x.
Okay, Atharva. That will be minus cos x. So this will become minus plus 2 cos x. This is your yp. So the solution will be y is equal to yc plus yp. Y is equal to yc plus yp will be our final solution. Fine. So that's the end of shortcut method. So in the next lecture, what we will do is we will learn variation of parameters. And at 10:45, I'll give you 15 minutes break here. And at 10:45, we will have our tutorial number 1. It will have 5 marks. I will give you the questionnaire at the start and the end of the 1 hour, and I will be with you for that 1 hour. And what you can do is you can go for submitting it after the end of 1 hour. So I hope you have your notes with you. If you don't have the notes, you have the textbook. Those I have given to you. The application and the PDF, both I have told you to download. That will also be with you. And you solve those questions in 1 hour. So we'll stop here. Take a break of 15 minutes. I'll give you the new link also. Join using that link. If you have any questions, you can ask.